Right, so these are now half angle formulas. So how they're formed is if you take a double angle formula and you solve for sine, you end up with this. But we now have an x, and we have a 2x in there, so it doesn't really work really well. So if we say u equals 2x, and then solve it, we would get x is equal to u over 2. Plugging those in, so x is now u over 2, this would now become cosine u. So if I were to plug in u over 2 in here, the 2's would cancel, giving us just u. But when you take the square root, you also get plus or minus. And this would be the exact same idea for cosine and tangent. So if you just think about it this way, sine is positive within here and here, correct? So if we were to come over here, sine would be, sine of our u would be negative. But if you cut it in half, it would now be here, which is positive. So signs are going to change as we move through. So one way we use half angles is we can find exact values with things that we can double. So if you double 15, and while we're saying doubles, you'll see why in a minute. So if we double 15, we get 30 degrees. That shows up on our unit circle. So if we have u over 2 equals 15, this means that u would equal 30 degrees. So sine of u would be 1/2, and cosine of u would be rad 3 over 2. So now if we wanted to find tangent 15, we could say that u over 2, see this is 30 over 2. So this would be tangent of 30 degrees over 2. That's why and this is why we double it. So if you double the 15, you get 30. 30 over 2 would be 15. It allows us to write it as a half angle. And so tangent is 1 minus cosine over that, or sine u over 1 minus over 1 plus cosine. I'm going to do the first one. So 1 minus cosine of u over sine u. And our u here is 30 degrees because it's tangent of u over 2. So our u is 30. So now if we plug that in, we get 1 minus cosine of 30 degrees over sine of 30 degrees. And then a little simplifying, cosine is rad 3 over 2. Sine is 1/2. And there's our complex fraction again. So again, we put a 2 here, a 2 there, and a 2 there. We're really only multiplying the top by 1, 2, but again, it's for reference. So this would be 2 minus rad 3 over 1. So it's 2 minus radical 3. So if we plug that in our calculator, tangent of 15 degrees, 2 minus radical 3, it's exact. So we found the exact value for tangent of 15. It's a pretty cool little trick. Let's do it again. So if we had sine of 75, again, it doesn't show up on our unit circle, but if we double it, we get 150 degrees. That does show it up. This means that our u would be 150 degrees. So this is going to be sine of 150 degrees over 2. So we're going to need sine of u. So if we go back up here for our half angles, sine of u over 2 is going to involve cosine. So our sine of u here would really be sine of 150 degrees. But we're also going to need cosine of 150 degrees to find this. So sine of 150 was 1/2, and cosecant is negative rad 3 over 2. So now that we have this, so is sine 75 degrees positive or negative in quadrant 1? The reason you're asking this, you'll see in a second. So we come back up here to our half angle. Sine is equal to the square root of 1 minus cosine u over 2. So square root of 1 minus cosine of 150 over 2. Remember, this is our u here. U equals 150 degrees. Okay, so cosine of 150 is negative rad 3 over 2 over 2. plus now. And we use our little trick inside again, but we do this just inside. So this equals square root of 2 plus radical 3 all over 4. Now we go back, and if you notice it had plus or minus because we're talking about a quadrant, right? 150 is in one quadrant, but what we're doing is half that angle. So when we plug this in, we're plugging in 150. That's a different quadrant than we're dealing with. So sine of 75. And so you want to always look at these with your double angle and look at the angle that you start with. So sine of 75 is either going to be positive or negative. Cosine of 75 would be positive or negative, so on and so on. So we want to use our all students take calculus to figure out what quadrant we're in. So which quadrant are we in when we have a 75? So remember that's 90. It's 180, 0, 270, 360. So that means we are in quadrant A. And in quadrant A, everybody is positive. So whether we had sine of 75 or cosine of 75, it would be positive. Now, if that had been sine of 192, then we know we would be in quadrant 3, and that would have been negative, so you choose the negative sign. But you can even just cheat. Really shouldn't be, but if you just do sine of 75, again, make sure your mode is in degrees. It is. Hit enter. It says positive. And then you also want to check your answer. And so plugging it in, we get the right answer. Now this one can be a little complicated. So if you notice, it's a radical is our main grouping function. So that's where you want to start. Hitting alpha y gives us our fraction. And then it's 2 plus second square root of 3, scroll down, put a 4, put an answer. But you can see it's positive when you plug it in. So if we had sine of 195, you'll see it comes out negative, so you know to choose the negative value when you do them. Okay, so now we're going to do more of what we did before. So you're going to be given a sine theta. And again, these are just practice. So we're going to find sine of theta over 2, cosine theta over 2, and tangent theta over 2 based on our original trig function. So we're in quadrant 4. We're over here, and that's why sine is negative. So cosine will come out to be positive. So a squared plus 1 squared equals 3 squared, subtract the 1, a squared equals 8, square root, plus or minus, oops, just plain old 2 rad 2, because he's positive. And then we can write them in. So sine is negative 1 over 3, so cosecant would be negative 3. Cotangent, cosine is 2 rad 2 over 3, reciprocal. And then tangent theta would be negative 1 over 2 rad 2, rationalize. Get that. And then flipping it, we get negative 2 rad 2 for our cotangent. So those are our 6 trig functions. So now we're going to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. So we go back up, not down. And we're just going to write these out. So we have 1 minus cosine u over 2, 1 plus cosine u over 2. 1 minus cosine theta over 2. And you can even see how it's written. And this is 1 plus cosine theta over 2. And then tangent is, we'll pick that one, 1 minus cosine u over sine. So verify them all. And we plug them in. We'll worry about signs in a minute. So this is 1 minus 2 rad 2 over 3 over 2. Again, complex. Common denominator here is 3. I know you want to think 6, but we don't need it. We're just trying to get rid of 3. So put a 3 there. You got to do top and bottom. So this becomes square root of 3 minus 2 rad 2 all over 6. Let me do it again. So we know that would just be now square root of 3 plus 2 rad 2 over 6. And then tangent would be 1 minus 2 rad 2 over 3. And then what was our sine theta again? Sine theta was negative 1 over 3. And complex. So looking to find out what the sines are now, we just want to look at the quadrant. So if we're here and this is our quadrant, we're doing theta is the angle up here, right? So that would be like, for this one would be something between 270 and 360. Let's just pick a random angle, pick something that's in there. So like, I don't know, 200 and something in between, 270 and 360, right? Like 290, okay? If we cut that in half, let's just make it 300. That's easy. Cut that in half, you would get 150, which means we are now in quadrant 2. So what we're dealing with here is sine. This would be sine of 300 over 2, which is sine of 150, which means we're in quadrant 2 for our actual angle, because we're not finding sine of theta, we're finding sine of theta over 2. So whatever theta is, we're cutting it in half. So this one is in quadrant 4, which means these are now in quadrant 2. You can also, the main way to do it though is this is 360, this is 270. So if we cut those in half, we would be 180 and 145. We can even just make that one 45, which means we're in this region, which is quadrant 2. So the only person here is sine. So sine is positive, this is negative, and then this is negative as well. All right, and we should check at least one with our calculator. So if we do sine, inverse sine of negative 1/3, that gives us our angle. That was our theta. Now you want to think of these as positive when you deal with them, not as the negatives, because if you half the negative, we're still in the same quadrant. So we need to convert it to a positive, and then if we take that angle and cut it in half, that would be what we're looking for. So what we're trying to find here is sine of theta over 2. So our actual angle was 340 degrees. That's where we were. So we can come back and actually say that this was 340 degrees. So cutting that in half would put us at 150 plus 20, 170 degrees. See, we're right in here for quadrant 2. And plugging that in, 340 over 2 gives us this. So inverse sine gave us that angle, converting it to a positive angle, coterminal. Dividing it by 2 and finding the sine. Look, our exact answer. It's pretty impressive stuff. All right, now I want you to try one. So you're going to hit pause and give it a shot. Hit pause now. Okay, so there are your answers. So hit pause to check your answers. And then afterwards, unpause it, and I will verify everything with the calculator. So make sure it's negative. A lot of times the issue is just not fully rationalizing it. This is a hard part to see sometimes. So if you see square root of 3/5, make sure you split it and rationalize it, or it won't match the homework. And then this again was quadrant 4, so halved would be quadrant 2. If you were in quadrant 3 and halved, then you could be within here and here. So you want to take each angle and modify them. Okay. Checking with the calculator. So inverse cosine gave us 78. But again, we are not in quadrant 1. We are in quadrant 3. So 360 minus 78 put us 281. Now we are in quadrant 4. Cosine of the quadrant 4 divided by 2 gave us a negative for cosine. So if you kept this original angle and did it, it would have came out positive. We need to make sure that it has a nice correct quadrant that we are in. That is what you were looking at. What quadrant are you in? Positive angles only, and it'll give us the answer. All right, thank you.